Okay. Section 3.4 called properties of logarithmic functions. Okay, here's something I want to show you. Does anybody remember if I have something like this, y equals a to the x, how you convert that to a logarithm? You remember?
Log A.
Log base a.
Y equals X.
Okay. Now let's see if you remember some vocabulary. Do you remember what this part of this equation is called? This is the exponent. What's this called? Does anybody know what the whole thing is supposed to be called together as a single thought?
Exponential.
You think? No, it's actually called a power. But people don't use that very. They use the word exponent to mean this, and quite often they use it to mean this because that's the only, and it's a variable to call it an exponential function. So, but anyway, that's the whole thing's called a power. Here's the base, here's the exponent. The reason why I bring that up is because this is equivalent to this, isn't it? Remember I had the little arrows going both ways. You can go from one to the other, right? They're equivalent expressions. Some is more useful than others depending on the context of what you're doing. However, what I want you to notice is that the x in this one is called an exponent. The x in this one is the very same x that it was here. This is also an exponent. And you're going, it's not a little, it's not, yes, it is. It's an exponent here, and this is an equivalent form. This is an exponent. So do you understand the words when I say, and this might be revealing to you, but exponents are logarithms.
Yeah.
Or logarithms are exponents. It's a fact. It really is true. Logarithms are exponents. They don't look like exponents because they're got this strange word. Everything's written out in big letters. We're used to exponents being little guys kind of perched up above something. That is not the case here. But logarithms are exponents, which means they have to behave like exponents because they are exponents. And you're thinking, okay, that sounds reasonable, but how do exponents behave? So let me remind you. This is how exponents behave, if you'll recall. Do you remember, without me demonstrating with numbers, do you remember what x to the m times x to the n is? X to the m plus n. So if you're trying to multiply two things with the same base, you add the little guys, right? X to the m divided by x to the n is m minus n. In other words, when you're trying to divide, you're doing a quotient, turns into a difference. Products turn into sums, right? What about x to the m raised to the n? X to the m times n, right? Just to complete the whole notion here, what is the, how do you figure, or how do you write the nth root of x to the m? X to the m over n. So this is something rather interesting, just something to notice. I probably told you this before, but I'm bringing it up again. Do you all recall, and I'll bring the two together here in just a minute, but do you all recall the what order of operations is? What do you do first? That is not true. Listen for a minute. That's PEMDAS, and please excuse my dear Aunt Sally's most ridiculous stuff, especially your age. But anyway, listen up. Shh. I always tell you that parentheses comes first. No, parentheses is an organizer. It says go to the innermost parentheses, go there, focus your mind on that, and apply order of operations. It's an organizer on how you apply order of operations, but the order of operations does not have parentheses in it. That's a crutch. That's a helper for you to remind you, look inside parentheses first. And once you're inside the innermost set of parentheses, ignore everything else and apply the order of operations to what's in there. But it is not part of order of operations. So if you eliminate parentheses, what's the first thing that you have to tackle if you're doing order of operations? Exponents. What's next? Multiplication and division in order from left to right, right? And then? Addition and subtraction. What seems to be missing? Roots. And they don't don't tell you about roots in grade school because you're not ready to handle them yet. But to really complete order of operations, it does include parentheses, but it does include roots. So something was added and something was taken away in the actual order.
Excuse me, my dear.
Okay, listen. So if what you're trying to do is actually the ultimate macro thing that you're trying to accomplish is to exponent something, exponent and exponent, you're powering. What do you do with these guys? This is what you're trying to do. This is what you do with the little ones. If you're trying to root something involving these two little things, what do you do with them? You come down one and divide. If you're trying to root something, that's what you do with little guys. You have to remember the proper order. If you're trying to multiply, ultimately that's what you're trying to do with two things that's with the same base, you add the little guys. So if this is what you're trying to get done, this is what you do with the little ones. Same thing here. If you're trying to get a quotient done, this is what you do with the little ones. So what do you suppose happens when you go to do this? What is x to the n plus x to the n?
You add.
You can't.
They're not like terms. There's nothing you can do. Mainly because you're already here. There's nothing to come down to. You're stuck. These are not like terms. Okay? Just a little mnemonic here to help you remember what. Now you're going, I'm multiplying. What am I supposed to do with that? Do I multiply those? No. Oh, I got to add. It's come down. Anyway, that's just a little mnemonic. It's just a pattern that happened to show up. Okay. This is how exponents behave. This one right here is not going to be addressed today. We're not going to address it ever. It never shows up. It can all be handled with this. You'll see why in just a minute. Because we can use exponents instead of fractions, which accommodates all of that stuff I just erased. This is how exponents behave. Since exponents are logs, that's how logs behave when you've got several things going on. This is what I mean. Log exponents. So if I have the log of, and I'm going to leave the base off. It could be the base anything. I'm not going to put a base b here. I'm just going to use log base 10 to get the information out. But it could be any base as long as they're the same. And you're going, what if they aren't? They won't do that to you in this book. So they will always be the same, and whatever it is, make sure you're true to that and report it at the end of what you're doing. But I don't want to write all that down. I want to focus on what we're logging. If I have the log of m plus the log of n, adding two exponents, that's the single log of their product. If you have the log of a product of stuff, then you have the sum of the log of each individual. Because here we had a product, went to the sums. And remember, this is how the exponents behave. That's how the logs behave, because logs are exponents. What? How do you suppose this behaves then? If I have the log of m minus the log of n.
Log m over n.
Yeah, one log of m over n. Positive 1 over negative 1. And if you have the log of m raised to the n. Now this one's a little trickier to see that it actually does behave like this. What do you suppose that is?
Log m.
It's the log of m times n.
Wait, you throw the.
You're used to naming this. You're used to, if somebody said, what is that? You say, that's an exponent. And somebody, when you look at this, and most people will say, well, that's a logarithm. But we know logs are exponents. So we have an exponent to an exponent. Becomes the product of the exponents. Main thing to remember is that when you have this situation here and you've got something powered inside the log, this little guy right here gets to come down around front. Which means when it was an exponent in its ivory tower and could not be accessed through anything algebraic means at all, if you're logging it, it gets to come down here and be a factor, which is very easy to deal with algebraically. So we take it out of its inaccessible ivory tower and put it down here and make it a factor. Now we can treat it with some algebra skills.
So after you bring it back to the other side, could you divide that n off? As like before, could you divide it off to solve for x on the other side?
Possibly, we'll get there.
Okay.
These are the three main transformations of these. The way exponents behave is the way logs behave. Now, if you want, I've got a proof for all three of these things. If you like, I can prove it to you that it works. The fact that they behave like exponents, is that enough for you?
Like in the top two, the bottom one, I stuck it.
When this is an exponent and you're exponenting an exponent, you multiply them. But remember, logs are exponents. So this thing right here is an exponent. This thing right here is also an exponent. I have an exponent to an exponent. It's not the whole log that's to the exponent, only the m is, it's true. But this is an exponent and logs are exponents. And the product, powering this becomes a product when you bring it down on front. This exponent times this exponent. Just like it was here. If that's enough, we can go on. Otherwise, I can prove it to you if you're interested. And if you are interested, but you don't want to admit it because your friends don't want to see it, then you can come and look at it sometimes. It's pretty easy to follow. It's actually in your book too. Example 1 is a proof of what we're going to do, but I don't want to do it for you unless you want to see it. Are we okay?
We're good.
Then I'm going to do a couple of expansions, and then I'm going to let you try it. This is where it gets kind of fun. People kind of like this. Once they see a couple of them, because it's a bit challenging, but it's still accessible, and you can do it mostly in your head. I like that, because I don't have to, move. Okay, so if I have the log of this, and this is going to look real ugly real fast, but you watch and see that all of these things get applied. You think about it for a minute, you'll get it. You watch. If I have the log of 3x to the third square root of y z to the 8th over 2, let's say w to the fourth root of z cubed, not z, a cubed, 8th root of b to the 5th. That's pretty dang ugly. This is how it expands. You watch as I write this down and see if you can understand how this expands using these 3 rules all at once. Oh, yeah, we did. Thank you. Hope it's not too glary. If you're watching this right now, look away. You're going to get dizzy. I don't think I'll need to plug in for just a minute. I hope it's not too glaring if you're watching this. Okay, so I'm going to expand this, and it looks really awful and terrible and horrible, but you watch as I expand it and see if you can see these 3 things coming into play here. It's going to be the log of 3 plus 3 logs of x plus 1/2 log y.
Yeah, this makes sense.
Plus 8 log z minus log 2 minus 4 log w minus 3/4 log a minus 5/8 log b. That wasn't too hard, right? Now, let's take one while we're over here on this very same video set here, right here. Let's take a really, really long one and see if you can condense it. Let's say we have 3 log x minus 3/8 log y minus 4 log z plus log 2 plus 1/2 log a minus 4 log b plus log c. So it's got this huge expansion here. Let's see if we can condense it into a single log with a single move, a single stroke of our pen here. Log of
X to the third.
numerator or denominator?
Numerator.
Okay.
Wait,
I thought
wait a sec.
It'd be the 8 y.
It's 8 through of what?
Y.
Yeah.
you want me to erase this?
No, it's not.
This is right?
Yeah.
Okay, what do you want to do with the next term?
Throw it
Divided
on
by.
You want it where?
the denominator.
Oh, in a denominator? Okay, so this going in the denominator, what will it be?
8 through y3.
Okay.
a y cubed.
Also, a z to the
Minus
fourth.
Okay, I'm gonna put a little hook on this to remind us it ends. So z to the fourth goes downstairs, right? That should be down and then,
And then upstairs is 2.
okay, and that should go in front.
Wait,
Square root of A. And the numerator.
Root of a, that goes in the numerator, right? B to the fourth.
And
and C on the top.
yes.
See, guys,
See, you guys are good at this. Okay? All right, for those of you watching this video, I'm going to, well, I have to leave it on so it'll be one full video, but we're gonna take a break for just a second and do a worksheet. If you have the worksheet when you view this, then it's all gonna work out great. And if you don't, you just have to sit tight for a minute while this thing plays on through. While we work on something, so. See you in a minute. I'll let you know when I'm ready to talk again. Okay. So, now let's see if you guys can do it. On your own, by yourself. Try not to get your friends help unless you absolutely must. The other thing I want you to do on this worksheet, right at the top, there are 8 statements, and I want you to decide if they are true or false. Because people think that they have these down in their mind, and then we throw something else out, and they go, no. I wonder if that is true or not. So we're gonna do the true, false, and then you're gonna do 3 expansions and 2 contractions. And I want you to do them right now before we move on. This is part of today's assignment, so if you don't get it done, you gotta finish it before you can get credit for this assignment. All right, get busy on this. Try to make these decisions by yourself. Try not to get your neighbor's help. And get the homework done. I'm gonna erase this because I want you to look it up here for a crutch. I hate to tell you that, but no crutches. See if you can do it without referencing anything. See if you can figure it out. If you need some help, that's why I'm having you do this, so I can come and help you. If you need it. It's 5 times x, 5 is going to be fun. Got it? Yeah. Do you smell?
So the way it's written here, you carry it through the exponents, it's the same way for everyone. Every single one of these things turns into a log of the type. It's 3 log x and the next thing will be 2 log of natural log. Same log is here, this one time. Is a log for every one of these types, same log. Okay. W is just behind the natural log. No x1 log. Only x1 doesn't have one. So it's just log. That's false. It just has to be a product to turn into some. Sums don't remain sums. So yes, you're false. It's false. What belongs to the x only? That's a product. It should be all 3 plus 4. They don't come out.
Mistake. Shortly.
One comes down in front of the wall, mark it, and I'll find it.
This square, is that just going?
I would try to see that before we start.
Okay, and then, so, is this like 2 minus 2 fifths log?
Yeah.
Yes. And then minus, maybe it's not anything. So, I would apply it to everything inside first. Just everything applies to every single one of these factors. So whether it's the 6, this would be y to the negative 6, this would be z to the 4, and this would be x. I would distribute that through before I started pulling together to good density. Yeah. Okay.
I have a question. When there's the negative there, can you plug it?
Yes, so you got negative. So in other words, this should have been downstairs and it would be positive. Because it's downstairs, it would turn out as a negative.
Okay.
But if you leave it up there and apply it the same way, it'll still turn out as a negative in front of it as it should.
Okay, and then this.
That should apply to every one of these before you start.
Okay, so this would be 5.
Yeah, it's 6.
Yeah.
Yeah, it's power. So if it's 6, y to the negative 6. Z to the 4, before you even get
Plus negative 6.
Yeah. Actually, no, that won't be squared there, that will be 2. Because what you did, what everyone's asking you to do is, I do this, actually, you did this much. A lot of people inside.
It's negative, it would just give them a piece of positive.
Yeah.
So, am I only doing just this, or like,
No, you have to distribute it every turn, that's the same.
You're not talking about.
Yeah. Yeah, change every single one of them. That's all. It used to be 6 log. Oh, that's on the bottom.
I thought that was interesting. And you were trying to tell me.
Yeah, but this is, the absolute value applies to both.
Yeah.
Corbin, do you remember that?
So it'd be X minus 2.
This will look good. Because you take that little thing.
Yeah. So that's all.
For-
So if this were like a 130, just put 3.
It belongs to all of them, it's just a big old house.
Yeah, that's the question. So on this one number 3, these 5 is still in. But with this one,
So like on the bottom one, it's easy.
I just got negative.
Doesn't change.
And
No deals. Bring it on over.
Anyone else need any help, or you wanna know what the answers are? Are you ready for them?
Would you give some like my freaking calculator sitting downstairs.
Chill.
Bro, you're so crazy.
Because I use it.
One more minute.
Oh, we try to use this. I bet you it is. Yeah, sure about that. You get to put the rod away.
So for this one,
You not use the button?
Okay, that was my question. No, like how do you
Well, I just.
Which case you have to come back. What? I just forwarded the whole
Why do you root over?
I brought it down.
Okay, you ready for answers yet? Anybody? Okay. Notice how they are numbered. It goes 1 and then across the page to 2 and then down to 3 and 4. And that's how I'm going to read them. So make sure you're reading. Don't read down as I'm going. Okay? Read the numbers in order. Here we go. Number 1, as we go across, and I'm just gonna read them in order. So it's false, false, true, true, false, true, false.
You actually explained why A is true. I got it right, but I'm not really sure why.
Number 8 is true.
Absolute value x, because 4 is always
Number 8 is true.
so absolute value x. Power is all about. But you can only log one. X would be an absolute value. Okay. If you finish this, then that part of this assignment is done. You still got the book part of it to do. If you didn't finish it, you have to finish it to get credit. You understand? Okay. Do you need to know the answers to the others to see if
Number 5.
Then listen carefully because I'm not going to read them more than once. Number 1 is 3 log x, and when I say log, I mean natural log. Okay. So it is 3 log x plus 2/3 log y minus 4 log z minus log w. Number 2 is log 3 plus 4 log x plus 1/2 log z minus 2/5 log y minus 3 log w. Number 3 is one of two things. You can have a 2, I'm going to read, it should be distributed. So this is the distributed answer. 6 log x minus 6 log y minus 4 log z minus log w. Number 4, the compensation should be log, and then in the numerator, the cube root of y squared, z to the 4th. In the denominator, x squared, cube root of w. For number 5, there's a couple of ways to express it. Here's one of them. You can have, all right, this is one way to do it. The log of the big old square root, it holds the whole parentheses in there, x, y cubed, a, over the 5th root of b to the 3rd. You can also have the log of the square root of x, y root a, over the 10th root of b to the 3rd.
Why would it be y root y?
Because the square root of y cubed has a pair of y's in it. I'm just gonna.
Square root of y.
Yeah.
Just show us some.
You want to see the last one?
Yeah.
Maybe. This is one way to handle this, and that is to distribute the 1/2 before you try to condense it. This is one way to handle it. So 1/2 log x plus 3/2 log y plus 1/2 log a minus log b. In which case, when you condense it, you get 1 log of the square root of x, square root of y cubed, which I'll come back and fix. That needs fixing. When this is an improper fraction, this needs fixing. Plus, I'm sorry, not plus. The root of a all over the 10th root of b to the 3rd. This right here has a y times a y times a y in it. I'm square rooting, which I usually leave off. So I have a pair of y's, so it really should be this. And really, truly, when you got all these square roots, and they are square roots, not different ones, it really should look like this. That really is what it should look like. But I would take this or that. But that's the best. That keeps me in a good mood while I keep grading the rest of your test.
Good thing this is the last question.
There is another way to do this one as well, and that is to not distribute it first, in which case you would have the log. What it would be is the log of x, y cubed, a, over the fifth root of b to the third. Now, where does that 1/2 go?
Over the whole thing.
Yeah, it belongs to all of this, which would be acceptable there, or you can do this as well.
Swatches.
Belongs to all of that.
That's what I like.
In which case, to get it completely and totally correct and proper, you should still take a y out of that.
Got it.
I would accept either one. Okay? If we were really correct, we'd rationalize that denominator. One of those rationalizing denominators is if this is a number, you should rationalize it. If it's a variable, we don't know for sure what it is, so it's not necessary.
There's one y on some basis.
I do not. Yeah.
Okay, so if you still have any questions about that, or you can't complete it, or you're not sure you got it right, come see me about it. We'll take a look. I got 2 more things to show you.
We need to turn this in.
You turn that, when you answer yes for section 3-4, that had better be done in case I collect it. So keep it until you for sure have a yes and it's either been collected or not. Okay, 2 more things to show you. One is exceptionally important and very easy to use. I love those kinds of things. So things are really critical, but really easy, and here it comes. As you've encountered so far, there are all kinds of bases. Base 3, base 5, there's even base 1/3, if you will. That's just crazy. Usually they're positive. I would hate it to do it if they were negative. We'll do that. But because there's only 2 keys on your calculator, some of you have said, "Well, I found it in my catalog." Great, go ahead and use it if you want to. I'm going to show you a better way. At least I think it's better. Consider this with me for just a minute. If I have a to the x equals n, we call that what? An exponent or a log? An exponent. What's its equivalent log?
Log base A, X log A.
Log base A of n equals x. So those are equivalent, right? They go together. One can be turned into the other. They're exactly the same thing. They would graph exactly the same way. Okay? Different forms of the same thing. Now I want you to consider this again. A to the x equals n. Here's something else that we can do to it now that you've learned about these properties. We can log both sides. If I were to log this side and log this side, that's a legal thing to do as long as you do it to both sides. It's algebra, right? It still stays equivalent if you log both sides. So you convinced? This right here is really this. X log A equals log n because of the rule for exponents, right? Well then, if I continue doing this and solving, if I solve for x, for example, I would get log n over log A. You agree with that? Well, look, when we started out with the same expression, using what I've taught you to do to change from one to the other, I got that x was equal to this. When I used the property over here and logged both sides and brought that down, or continue solving for x equals this. Since we started with the same expression and x was the same thing, then this circle ought to equal that. What do you think? By substitution? So the log base A of n is equal to the log base 10 of n over the log base 10 of A. That's a way to evaluate something that isn't log base 10 or log base E. What I'm trying to say is, in this expression right over here, in this thing that I was trying to link to, I could have, instead of logging both sides, I could have natural logged both sides. That would have been the same thing as long as you do it to both sides. Which means I would have ended up with natural log of n over natural log of A. So this also equals the natural log of n times over the natural log of A. So it doesn't matter which of your keys you use as long as you don't mix them up. Don't do common log n over natural log A, that would be dumb. Stick with the log that you choose. This is how it's useful. This is called the change of base formula. It's very, very useful. If you want to figure out, for example, without looking it up on a table book like I showed you yesterday, if you want to figure out the value of the log base 7 of 18 Very strange and obscure. What you would do yesterday is say, okay, well, I'll write x. So that'd be 7 to the x equals 18. That didn't improve the situation at all. We don't know 7 to what is 18. But whatever this is what this will find, and I now have a way to do it. I can take common log or natural log, I like natural log, of 18 over the natural log of 7. That's what this just said. The natural log of the big guy on top, natural log of the little dude on the bottom. You divide those two things and it will tell you what that is. Do that. That thing should turn out to be something like 1 point something, because if it were 2, then we get a 49.
If you do this, natural log or log, does it matter?
It doesn't matter, just don't mix them up. Stick with it. So if you choose log and I choose natural log, I guarantee we'll do the same thing. Now here's your big problem, folks. Listen, this is the big error that's caused when people do this. It has to do with your calculator. As soon as you go to calculate this by saying, okay, I'm going to use natural log, this is what your calculator does. It says natural log parentheses. And you put in 18, and if you're not looking at your screen, then you'll go divided by the natural log of 7, and it will throw down a parenthesis there. You'll close that, and that is not what you want at all, not even remotely. You want this, the natural log of 18. Close the damn thing. Close it. Because it will put one here. You have no choice. You have to close it. Then divide by the natural log. It'll slap one down, put a 7, and close it. Make sure you're closing your logs before you do any operations on them, because you're logging inside a log. It's horrible. So, see if you can calculate that. We expect to get 1 point something, don't we? Because if x were 2, then I would have had not 18 there, but 49 or something. Okay. So we go log. I'm going to do this. Log 18. 1 point. Close it. Divided by log 7.
Speed.
And we get, whoop. Put a plus sign in instead of now. Okay, get 1.485?
Yep.
Okay, now, take 7 raised to the answer. Amazing. It is the exponent.
Wait.
Logs are exponents. Okay, so that's a way to evaluate something that's strange and obscure, and even if you change it to an exponent, you can't tell what it is. This is called the change of base formula, and you can use either one of your log keys to evaluate a base of any kind. Okay, now, I want to show you one other thing that's a little bit weird that you might not expect. It has to do with the fact that products become sums, quotients become differences, and quotients that are unit fractions become negatives. It's weird. Watch. If you have the log base of fraction, so the base is 1 over b, of x equals y, you have that expression, you got this strange fractional base. Then can you change that for me? Can you change that logarithm to an exponent for me?
That'd be 1/6. It's the y.
That's a b.
Oh, I thought this.
I know.
1 over b.
1 over b to the y equals x. So those are equivalents, right? Do you understand that this thing inside here is exactly the same as this? That is this? You with me? To knock it off, really. I'm getting tired of this. You're being juvenile. I don't care. If you're going to sing, get out. I want to talk about math. Here we go. Do you understand that this ring thing in here is the same as this? Everybody good? Which means that that's the same thing as b to the negative y equals x. You following? Now, take that thing right there and change it back to a log form.
Log base b. Of x equals y.
Good. Now, I'm going to take and divide. Well, I'm going to either multiply through or divide both by a negative, and I get this. Yeah, that's nice algebra move. Okay, so we started out with that. And we followed some things that were equivalent all the way through. So that expression, this expression are the same. In changing this to its reciprocal, we inherit the negative sign, basically. So I guess what I'm saying is this. If you have the log base 1/4 of x, that is exactly the same as the negative log base 4 of x. They are the same. It's a very strange thing. You went from reciprocals and picked up an extra negative along the way. But here's why that worked. It's not magic, and it's not something you really need to memorize. I'm just saying, if you have a fractional base, you can expect an extra negative in answers. If you want to go back to a positive base here. Does the calculator calculate with fractional bases? Sure. In other words, if you had to evaluate the log base 1/5 of 4, you could do that with the change of base rule I just taught you. That would be the log of 4 over the natural log of 1/5. But do you remember I told you that when you log a proper fraction, you get a negative answer? So I have a positive over a negative. So that thing's going to be a negative answer. So if you use the change of base rule and leave that 1/5, that's fine. You need to understand that that's the same thing as the log of 5, base 5 of 4, negative i's. Because look at that. If I use the change of base rule over here, I get a negative on the whole thing. Log 4 over log 5. These two are equivalent. Weird. Okay. All right. Those are the two things I want to show you. Mainly the change of base rule. You got to be able to apply that anytime it's necessary. And then you need to be able to expand and contract logs, and make sure that you go over these. If you don't understand for sure and are really clear in your mind why these are false and true, you might want to discuss that with somebody or with me until you're certain, because those are the common mistakes people make with logs. Okay? Well done. You got lots of time, so. Stop looking. Hey, folks, anybody have one of these? No donuts for you on Friday unless I get this. That tomorrow, Friday, you get it to me. If you don't get a donut. And I'm not gonna give in. You're all gonna sit and watch us eat them. I was missing 11, now I'm missing 8. You know who you are. If you have lost your blank one and you need another, I have other copies. Don't feel bad about coming up to get another one. But make sure you get it into me by Friday.
Oh, you let's go.
Oh, whoever's viewing this, I'm sorry you're still watching. I meant to cut it off. Bye.
I'm missing like